Everyone, welcome to section 8.1. In this section, we are going to be learning on how to solve systems of linear equations in two variables and applying them on certain applications. So when we're solving a system of linear equations, we have more than one equation and two different variables. So the thing that we want to do first is the first thing that they're asking us to do is to determine if the order pair is a solution to the system. So the solution is actually already given. So what we're asked to do is to check if this is the actual solution. So to check if it's the actual solution, we're going to have to substitute this x coordinate and this y coordinate into both equations. So we have 2x plus 6y equal 24. Now we're substituting x to be -3, so 2 times -3 plus 6 times 5. Does that give us 24? And that's what we want to check. So here we get -6 plus 30. Does that give me 24? 24 equal 24. That is correct. So it's true for the first equation. Now we have to do it for the second equation. X plus 5y is equal to 3. Well, now we're substituting the value -3 plus 5 times 5. Does that give you 3? And here I get -3 plus 25. That's positive 22. Does that equal 3? No. So that means that the solution, -3, 5, is not a solution. Is not a solution to the system. So it doesn't work. So this point, not a solution to this. Oops, 1 second, not a solution. Now that's when we're trying to check. So similarly, we're going to substitute 0.5 into this equation. So we want to check if the point 0, 1/2 works. So if that's a solution for both of the equation. So let's do 5 times 0 plus 10 times. Remember, this is the x value, this is the y value. 1/2, does that give me 5? Well, 5 times 0, that's 0, plus half of 10, that's 5. 5 equal 5, that is correct. But we have to check now for the second equation. For the second equation, we have 22 times 0 minus 6 times positive 1/2. Does that give me -3? Well, 22 times 0, that zeroes out. Negative 6 times 1/2. So -6 times, what's half of -6? That's -3. Does that give me -3? Yes. So for both equations, the point satisfies. So the point 0 and 1/2 is a solution of the system of equations of the system. So it does match. So that is just to check. Now, what are the possibilities we can have when we have a system of equations? We can have one unique solution. These are the different possibilities. You can have one unique solution, which is a system of equations represents intersecting lines at exactly one point. So you have two lines, they intersect at one single value. That means you have a unique solution. You can have no solution, meaning that there's no time where they're going to cross. You will have parallel lines. That means that the system is an inconsistent system. By the way, on the first part, if you have an intersecting line and you have a unique solution, it's called an independent system. The system is independent. That's for the top part. For the no solution, you have an inconsistent system and you do not have intersections and the lines are parallel lines. Now you can also have the third case, which is infinitely many solutions. So any point can work, and that's because the two equations are the same actual line. Can you have that? Absolutely. So if you have a system of equations and they represent the same line, so maybe it's a multiple of the other. So for example, what would that look like? For example, 5x plus 10y is equal to 25. If I divide everything by 5, this is x plus 2y equal 5. So these two lines are the same. If just one is a multiple of the other. So if I multiply equation 2 by 5, you get equation 1. So these two are the same line because it's just a multiple of the other. So they will be this exact same line. That means that all of the points will satisfy both equations. Now, how do we solve? There's two methods on solving. When you have the same line, these two lines are dependent on another, and you have infinitely many solutions. So you can have one solution, no solution, or infinitely many. Those are the three potential cases you can have for a system of equations. Now, how do we actually solve a system of equations? And there's two methods in this section that we're going to have to learn. There is the substitution method, that's method one. This is one way to do it. And then there's the addition method, which is also called elimination method. So it depends on the textbook that you're using. Sometimes you'll see it as an elimination method. Sometimes you'll see it as the addition method. When you are asked to, this is method number 2. So we're going to go over both methods because on the exam, I will require you to learn how to apply each method. So I'm going to ask you to do substitution on one method and then elimination on another question. So you have to be confident on how to do both of these methods. So the first method is called substitution. The goal is to first, we want to check which one is the isolated variable. We want to be able to isolate everything on one single variable. And then once it's isolated, we're going to substitute that value into the other equation. And then we're going to solve the resultant equation for one unique variable. Once everything is on a single variable, then we go back and solve for the original value for both equations. So if you decide to choose first y and then x, then you could do so. So you pick a variable that you want to start substituting. And then on method 2, that means that you're writing both equations. So this is in the terms of standard form, ax plus by equals c. Then you want to create opposite coefficients. So you want to be able to cancel one variable. You want to delete one variable so everything is only one. So you add. So you can modify, multiply, and add to kind of cancel things out. We want to create a positive coefficient so then you can cancel one of the variables. And then you add, and then that way you are only with one variable left. So we are going to perform both of these methods in this section. So let's begin with question 3, solve the system by the substitution method. So step 1, they're already telling us they want us to use substitution. If they're wanting us to use substitution, that means that we want to isolate one variable. So choose which one you want to isolate. And I'm going to choose the second equation, 5x minus y equal negative 26. And I want to isolate y. You choose the variable that you want to isolate. It looks simpler to isolate y because all you have to do is bring the y on this side and the 26 on this side. So then you have y is equal to 5x plus 26. See how the y moved to the other side and the 26. So y equal 5x plus 26. Now you have your other equation, which is 2x plus 3y equal 10. But I already have a value, an equation that's solved for y. So I'm going to substitute, that's a substitution method, into the second equation and the equation below. So now it's going to have 2x plus 3 times y, but y is in terms of x. 5x plus 26. So see how I'm using different colors? So I'm inserting y into the y of the other equation is equal to 10. Now everything is in terms of one variable. Now everyone is in terms of x. So I can solve for it. So let's clean it up. 2x plus 15x plus 20 plus. So I'm distributing 3 times 5, that's 15, and 3 times 26. So let's do, what's 3 times 26? That's 78 is equal to 10. Now I'm going to combine 2x and 15x. That's going to give me 17x. Hello, everyone. Welcome back to section 8.1. We left off on question 3 on solving a system of equations. So we have 2x plus 15x plus 78 equal 10. I'm going to solve for x, and then I'm going to move the 78 over to the other side, and then I'm going to get negative 68. I'm going to divide both sides by 17. And that's going to give me x is equal to negative 4. Now I found one solution. I need to find my y. So since I found my x, I'm going to substitute that into the equation that I had found of y equal 5x plus 26. And we're going to substitute negative 4. So it's 5 times negative 4 plus 26. That's going to be negative 20 plus 26. That's a 6. So my solution is negative 4 comma positive 6. And that should be the intersection of negative 4 up 6. And that's exactly the solution that we see here. So this means we have one solution, one unique solution, and this is called an independent system. So we found an independent system with one unique solution. And we are able to go back and check and satisfy if negative 4 and 6 is really the solution. So let's see if we plug it in. So we have 2 times negative 4 plus 3 times 6. Does that give me 10? So this is my x, this is my y. I have negative 8 plus positive 18 gives me 10. 10 is equal to 10. Yes. So it satisfies that first equation. And then if we do 5 times negative 4 minus the y, which is a 6, that should be negative 26. So we get negative 20 minus 6. Is that negative 26? Yes, negative 26 is equal to negative 26. Therefore, that is my solution. So the point negative 4, 6 is a solution for my system. Now we're going to do the same question. Now we're going to use the addition method or elimination method. So now when we're doing elimination or addition, we want to make sure we have opposite coefficients. What does that mean? So I notice that I have a positive and a negative sign on a plus and a minus. That means that's the variable that I'm going to eliminate. I want to eliminate y. To eliminate y, I'm going to have to multiply the denominator by a value of a positive 3. If I multiply 3 times the bottom equation, so the top is 2x plus 3y equal 10. And the bottom equation, if I multiply it by 3, 3 times 5 is 15x. And then I have 3 times the negative y, it's a minus 3y, is equal to 3 times negative 26. So if I have 26 times 3 is negative 78. And then I'm going to use addition. So then I have 2x plus 17x. I'm going to add vertically. Then you add, that's why it's called the addition method. So then I'm adding those two. So 2 plus 15 is 17x. And that's going to be this solution. And then I have a plus 3 and a minus 3, which are going to cancel, is equal to negative 68 because you have a 10 plus a negative 78. Then you solve and you get x equal negative 4. Oh, wait a minute. I kind of knew that already. Now, since I solved for one of the variables, I can take any of the equations. So you can take the first 2x plus 3y equal 10, and I'm going to back substitute it into the equation. 2 times negative 4 plus 3y equal 10. I get negative 8 plus 3y is equal to 10. And then I solve, bring the 8 over, I get 3y equal 18. And then I solve and I get 6. Oh, there's my point, negative 4 comma 6. And that is indeed a solution. And we check that solution. So we had to use addition here to get the same answer. So it doesn't matter if you use elimination or you use substitution. If it has a unique solution, it should be the same regardless of the method that you do it. Again, I will require you to know how to do it both ways, and then you will be able to successfully be able to learn how to do both methods here. Now we are going to do question 5, and then question 5, before I attempt question 5, I notice that there's a sign, a plus and a minus. I'm going to use the addition method. Here I'm not specifying which method I want to use, but I'm going to pick addition. But before that, I notice that I have decimals. So that means I'm going to start by multiplying everything by 10. So then I can get rid of the decimals. So I want to get rid of my decimals. So I'm multiplying top and bottom by 10 first. So I'm going to multiply this by 10, this by 10. Well, this one will be, I'm actually going to have to multiply the second one by 100 because that's 2 decimal places, but the first by 10. If I multiply the top by 10, I'm going to have 50x plus 3y is equal to 14. If I multiply the bottom by 100, I'm going to get 20x minus, so 2 times 1, 2, 10. 10y is equal to 28. Now, you're going to say, okay, well then, what am I going to do here? I'm going to try to cancel some terms. So I'm going to cancel, well, what do you want to cancel? You can multiply the top. I'm going to cancel my x's. I want to cancel x because I have 15 and 20. So I'm going to multiply 50 by a negative 2 and the bottom by a positive 5 because I'm going to have both to be 100. So if I multiply by negative 2, I'll have negative 100x minus, so I'm distributing, 6y is equal to negative 28. When I multiply the bottom by 5 and distribute, I'm going to get positive 100x minus 50y is equal to, if I multiply 28 by negative 5, if I multiply 5 by 28, it's going to be a positive number of 140. So then my x's will cancel. I have a plus and a minus. I have a negative 56y is equal to a negative value. And that's going to be negative 56y is equal to 140 minus 28. It's 112. Then I'm going to divide both sides by negative 56, and that's y equal negative 2. So I just solve for one of my variables. Y is equal to negative 2. Now, I solve for one of the variables, I'm going to substitute into one of the equations, either equation 1 or equation 2. I'm going to solve it to equation 1. So it's 5x plus 0.3y is equal to 1.4. But I'm substituting negative 2, so it's going to be 5x plus 0.3 times negative 2 is equal to 1.4. Okay, well then, if I do a cleanup, I get 5x minus, well, what's 2 times 0.3, 0.3? It's minus 0.6 is equal to 1.4, and then I bring the add 0.6. That gives me 2.0, and then 5x, and then divide by 5. So then x is 2/5. Or 0.4, whichever one. So then my solution is the point 2/5, comma, -2. And that is a solution for my system of equations. Now, for number 6, there's another system of equations, but now I have 2x plus 4y equal 4, and then y equal 5x minus 7, 7 over 4. Now, there's two things. You can use, because already, so notice that we have y equals something, 5x minus 7/4. So then we can easily use substitution. And that's what we want to use. We want to use substitution method. So I'm going to use substitution. So that means I'm going to take this y and substitute it to the top equation. So I have 2x plus 4y, but y is 5x minus 7 over 4. Everything is going to be in terms of x. Then I'm going to multiply it out. And then I have 2x plus 20x. Now a 4 times a negative 7 over 4, it's a minus 7 because the 4 on the top and the 4 on the bottom will cancel, is equal to 4. Now I have a 2 and a 20, that's 22x minus 7 over 4. Bring the 7 over, I get 22x is equal to 11. Divide both sides by 22, I get x is equal to 1/2. The 1/2 comes from the 11 over 2. They're divisible by 11. And then I reduce. You reduce your fraction. So now that I solve for one of them, I'm going to back substitute into the first equation. So it's going to say, okay, well, now I have to back substitute. So I have y equal 5 times x, which is 1/2, minus 7 over 4. But this is 5/2 minus 7 over 4. Now, when you subtract fractions, you need a common denominator. That means I'm multiplying the top and bottom by a 2. And this changes as 10/4 minus 7/4. That gives me a total of 3/4. So then this becomes my y term. So my solution, it's the point xy. In this case, my x is 1/2, and my y is 3/4. Again, this will make a unique solution of my system of equations. If I look at the next question, question number 7, I'm going to have to do some pre-work. So I have to do some prep work first. So I'm going to multiply it out and rewrite the equation. So if I rewrite the equation, I have 3x minus 3 plus 10 is equal to negative y. And then here 6y minus 30 is equal to 4x minus 28. I'm going to rewrite this in standard form. So all of the x's on one side, x's and y's, all the variables on one side, all the constants on the other. So I'm going to rewrite it as ax plus by equals c. So then I'm going to combine here. I have 3x plus 7 is equal to negative y. I'm going to bring the y over and the 7 over. So it's going to be 3x plus y equals negative 7. I'm going to change the color. 3x plus y equal negative 7. And then over here, I'm going to change the 28. So I have a negative 30 and a negative 28. It doesn't really matter which one I move. I can move the 28 over here and the 6 over here. This becomes 4x minus 6y is equal to negative 28. So if I have negative 30 plus 28, that's a negative 2. So then I have a 4x minus 6y equal negative 2. Now, again, from here, I can use elimination or the addition principle. I'm going to use the addition method. I have a plus y and a minus y. So I'm going to multiply the top equation by 6. So then I have 18x. So addition to eliminate my y. So it's 18x plus 6y is equal to negative 42. On the bottom, I have 4x minus 6y equal negative 2. I have 22x because 18 and 4 is 22. The y's will cancel, is equal to negative 44. I'm going to divide both sides by 22, which is half of that, so it's minus 2. So I get x to be negative 2. Now that I solve for one of them, I'm going to back substitute. Into 3x plus y equal negative 7, which is the first equation. So it's 3 times negative 2 plus y equal negative 7. Negative 6 plus y equal negative 7. Bring the 6 over by adding 6. I get y equal negative 1. And my solution now becomes negative 2 comma negative 1. Again, this is my unique solution after I've checked. So now, again, I'm making sure that I am substituting back into the original. You could have plugged it in into 4x minus 6y equal negative 2, and you would get the same solution. So it's one or the other. And when you do those calculations, you should get to the same answer. Let's say that you decided to do substitution, you would still get the same answer regardless. And we are going to try substitution on the next question. You can kind of distinguish if they're in a certain format. It's easier for you to do addition than substitution. And it's really obvious when you use the substitution method because one equation it's already solved for. So let's use the substitution method here. So I'm going to substitute. So I have 10x minus 5y equal 30. I'm going to substitute this equation into y. So into here. And that's going to be 10x minus 5 times 2x minus 6 is equal to 30. And then, well, we have 10x minus 10x plus 30 equal 30. I have a positive 10x and a minus 10x. This cancels. And this gives me 30 equal 30. Is that true? Yes. This means that you have infinitely many solutions. If you have infinitely many solutions, this is a dependent system. If this is a dependent system, you are able to have this equation. The solution is x comma y, but everything should be in terms of one variable. So it should be x comma 2x minus 6 because that gave you that independence. So whatever value of x you choose, you will always get the same solution. So x comma 2x minus 6, where x is any real number. And this is your solution actually, because since you have a dependent answer, a dependent solution, you write everything in terms of one single variable. Okay, so this is called a dependent system. And then just reordering everything on one single variable. Now, number 9, I'm going to rewrite it. So again, you're going to have to do some pre-work here. I'm going to have to multiply that first equation by 3 to get rid of the denominators and those fractions. And then on the bottom, I'm going to multiply everything by 2. So once I do that pre-work, I'm multiplying 3 by every single thing. So 3 times x is 3x plus 5y because the 3 on the top and the 3 on the bottom will cancel is equal to 1. Again, the 3 on the top and the 3 on the bottom will cancel. And the bottom, the 2 will multiply by 3 over 2. The 2's will cancel, and I get 3x. And then the 2 times the 5, I get a plus 5y. And then 2 times 2, that's 4. Now, notice that they're very common, so I'm going to use, let's say, the addition method. And I'm going to multiply the top by a negative 1. So then it can cancel. So I have negative 3x minus 5y is equal to negative 1. And on the bottom, I have 3x plus 5y is equal to 4. And then I combine them, and then notice how this zeroes out. 0 plus 0 equal 3. Does 0 equal 3? No. So this is no solution, which is called an inconsistent system. The system is inconsistent. Oops. So it's an inconsistent system. There's no solution, and that's all you can do. So once you find something that does not match, then automatically you do not have a solution. So let's do the last two questions here, which are going to be application questions. So let's go ahead and read those first, and then let's see what we can get out of these. So let's start by reading the question. So David borrowed a total of $10,000 to pay for his final year of graduate school. He borrowed a part of the money to his school with the Perkins loan. So he's asking for a loan, charge 5% on simple interest, and the remainder of the money was from his aunt at a rate of 1.4 simple interest. At the end of the year, he had to pay $428 in interest. How much did he borrow from each source? Well, first of all, we have to set an equation for interest. So the interest that we have, so the equation is I equal PRT. This is simple interest after how many, after how long? After 1 year, at the end of the year. So T would be 1. Now you have two equations, so you will need two why two equations? Because he borrowed from two different people. So he borrowed from the loan, and he borrowed from the from the Perkins loan and from his aunt. So you're going to have two equations. The amount equation, so how much he borrowed. So the borrowed equation. So X amount plus Y amount is equal to $10,000. So that's how much he asked for at the beginning. And then, well, some of the money came from the loan, so 0.05 x plus 0.014 y, and that gives an interest of $428. So you will have an interest equation and you would have the total equation. Now here, this is your system of equations. You need to solve for x, you need to solve for y. So what I'm going to do is I'm going to use the substitution method. And then I'm going to solve for x. So if I solve for x or y, I get x is equal to 10,000 minus y. Now I'm substituting that into equation number 2, so it's 0.05 times 10,000 minus y plus 0.014 y is equal to 428. So this is where you want to have your calculator in handy. You're going to multiply it out. So it's 0.05 times 10,000. That gives me a total of 500. Minus 0.05y plus 0.014y is equal to 428. I'm going to isolate it and bring the 500 over. So bring this over and combine the y's. So negative 0.0y plus 0.014. It's a negative negative 0.036y is equal to negative 72. So then divide it out, negative 0.036, and that gives you the total amount he borrowed from $200. So y is 200. That's the amount from his aunt. Now, how much did he borrow from the loan? Well, because you have an equation x and y, you're going to substitute. You're going to have 10,000 minus y. So x is 10,000 minus $200. This remaining amount, it's $8,000. So the resulting amount is David borrowed $18,000 from Perkins, so you're separating the money, and $200 from his aunt. Again, we had to create this system of equations where we were able to distinguish, okay, the total amount that he borrowed and the interest equation. That makes your two systems of equations. For question 11, it's a quite different approach because you're using distance, rate, and time. So a plane flies from Atlanta to LA. The wind, so with the wind, so first it's saying against the wind. So when you're against the wind, you're going slower. And the return is with the wind, and it only takes 4 hours. So when you're going from Atlanta to LA, it's 5 hours, and that's the time it takes you 4 hours. When you're coming return trip, you're only 4 hours. If the distance, so you know the distance from Atlanta to LA, it's the same distance on both go and come, the return and the go. It's the same. The distance is 3,200. And then you want to find the speed of the plane. So to find the speed of the plane, still in air. So you have two different things. You have x to be the speed in the air, and then you have y, the speed with the wind. So then when we're doing a setup, and they're always going to be the same, we have distance equals rate times time. And we are going to do a setup between with the wind, with wind, and without wind, or against the wind, if you will. That's the setup that you want to do. So first you have your distance. So distance equals rate times time. The distance is the same both ways. The distance is 3,200 for both kilometers. Now the rate here is with the wind. So it's x plus y. And the time here, when you're with the wind, it's faster. So this is 4 hours. And then if you're against the wind, it's x minus y because now you're going at a slower and you're taking 5 hours. Now, when you are creating yourself rate times time, so you have d equals rate times time for both, you have two equations to recognize. So the first set is d is equal to rate. So the distance here, the distance is the same, 3,200 equals rate times time. It's going to be equal to 4 times x plus y. And then you have 3,200. Oops, your second equation is equal to 5 times x minus y. And then you clean it up, you do some pre-work. This is all pre-work, by the way. We haven't done our equations. So we have 4x plus 4y is 3,200. And then you have 5x minus 5y is 3,200. Now, you may want to use elimination in this case because you have the plus and the minus. But before I do that, I'm going to divide this or multiply this by 1/4, multiply this by 1/5 to kind of simplify out my equation. 3,200 is divisible by 4 and divisible by 5. If I divide it, I get x plus y is equal to 800. So 3,200 divided by 4, it's 800. Then I have x minus y is equal to 3,200 divided by 5 is, punch that on your calculator and you should get 640. Well, now you have the plus and the minus. You can use the addition property here. And then the y's will cancel. I get 2x is equal to 1,440. Then divide both sides by 2. I get 720. So in this case, that means the distance per hour, the speed per hour of the plane. So remember, that's the speed in the air. Now, if I back substitute and I have x plus y to give me 800, and I plug in 720, 720 plus y is equal to 800. That gives me y to be positive 80 because I subtract 720. and I get 80. So that's the distance that's the speed with the wind. So then if I figure out my x, so my x is 720 kilometers per hour. That's the speed of the wind. And then 80 is the speed of the wind. 80 kilometers per hour with the wind. And with that, we are able to solve our system of equations. And with that, we finish section 8.1. So make sure that you guys are practicing. The setup should be the same for all the questions that relate to distance, rate, and time. And whenever you have with the wind and against the wind, this is the setup you want to do. And with that, we finish section 8.1. Thank you, and I'll see you guys on the next recording. Bye.